Hello guys, welcome back to Computational Thinking class, and as I mentioned, I will make videos about how to solve the rubric problems. So today I will share with you on how to solve rubric 3. Okay, let's go to rubric 3. Okay, I hope you already tried to solve these problems by yourself. And I'm just making this video to help you preparing for your midterm exam. Okay, so let's start. Question on rubric 3. The first one is this one. And I think this question is already, you already work on this on rubric 2, So this is a repeating problem from rubric 2. So I will not go too long on this, You already know that the question, that the answer is farmer B, Okay, oops, sorry. Okay. The answer for this is farmer B. Hope there's no question about this. If you have questions, then one option is to pause this video. You can pause this video, read again the problem, and then try to solve it by yourself. And the answer is farmer B. Okay, let's move on to the next. Okay, the next question is this. So this is about Donna, a cat lover, has 3 cats named Nero, Champagne, and Magnum. Donna weighed her cat and tried a scale that had not been used for a long time. Just when Donna was about to weigh Nero, Champagne, and Magnum together, suddenly the scales broke. Help Donna to gain weight in kilogram of her 3 beloved cats. Write only the numbers. Okay, so the problem is, you know the problem? The problem is she wants to know the weight of Nero, Champagne, and Magnum together. She only knows these 3 information. The weight of 2 cats are like this. So read the problem. You can pause this video and read the problem first, and then try to think creatively to find the solution. What is the easiest way to solve this problem? You can pause this video first and think about it. Okay, So I hope you already know the answer, The easiest way to solve this is to add all and then divide by 2. Because if you add all of this, then you know that Nero, you have 2 Neros here, You have 2 Champagne here, you have 2 Magnum here. You just have to divide by 2 after adding all. Okay, I think it's clear, It's quite easy for this one. Okay, so the answer is 32 kilogram. 9 plus 13 plus 10. Okay, let's move on to the next. So this one is about sequences, Actually, this is sequence. My sister is playing with blocks. She wants to move the entire arrangement of the blocks on the far left from A to the far right side, She wants to move the blocks from A to the far right, the C, She can only move 1 block at a time, and during each transfer process, the smaller block cannot be under the larger block. To help with the transfer process, my sister may use the middle side for a while. If the number of blocks arranged in A is 3, then it takes at least 7 times of blocks displacement, until all blocks can be moved to C, from A. And the steps are like this. So first one, you move the top block to C, and then move the second one to B, and then move again from C to B. Because remember the rule here, the smaller block cannot be under the larger block. That's the rule, Okay, and then from A, move the largest one. So you already have 1 solved here, For the next one, you can move the top one here, and then move the second one here, and then finally move all. Move the rest of it, the top, and you get 3 blocks here in C. So if you want to arrange 3 blocks, it will take at least 7 displacement. Yeah, the minimum displacement will be 7. Yeah. So this is actually the problem of Tower of Hanoi. Yeah, if you're interested, you can click this link here. Okay, this is, you can click here actually, or you can try other links as well. Yeah, you don't have to use this, but this is one of the links that are available, yeah, to simulate the Tower of Hanoi. And then the formula for Tower of Hanoi is actually 2 power by n minus 1, in which n represents the number of disks and Tn represents the minimum number of moves. Yeah. So if you have this question, what is the minimum displacement of the block if there are 7 blocks arranged in A? Means that the n is 7 here. Yeah. Okay. So because n is 7, then you can replace this with 7. So you can just calculate 2 power by 7 minus 1. So you get 127 moves. Yeah, okay. So I want to, I will try to click this link, yeah. And you can also click this link if you want, yeah. Let's start with the 3 disk first, yeah. So let's try to solve this. Yeah, see? This is the way to solve 3 disk, yeah. Okay, you can increase this into 4, for example. You can try to solve it again. Yeah, and I hope you have time, yeah, to also simulate for 7, yeah. For 7 disks, you need 127 minimum moves, yeah. You can try to simulate this if you want to know whether the whether we solve the problems correctly or not. Yeah, okay, 127. Okay, and basically the equation is 2 power by n minus 1. Okay, I will stop here because it will take some time to solve this problem. Yeah. Okay, I will stop this. I will stop it. Okay. Okay, let's move on to the next question. Okay, now the question is like this. Agria likes playing number cards. One day, he shuffled 10 cards and put them on the table. The order that appears is as follows: 1, 3, 2, 4, 5, 7, 8, 6, 9, 10. He wanted to sort the cards. So the goal is to sort the card. Oops, sorry. Oops. Yeah, okay. Sorry, yeah, my bad. Okay, so the problem is to sort the cards, but he could only swap the positions of 2 cards that were right next to each other. For example, he can swap the position of the number 1 with number 3, which is right next to it. So remember the goal is to sort the card, but you also need to know the constraints. Constraints are, yeah, again, this is the goal. So for every problem, remember to always define the goal and remember to always define the constraint. This is the constraint, yeah. He could only swap the positions of 2 cards that were right next to each other. Yeah, this is the constraint. Yeah, and the question is, what is the minimum number of exchanges Agria must make so that the numbers are ordered in ascending order from smallest to largest? Yeah, this is the goal again, yeah, to make sure about the goal again. She wants to make it ascending order, yeah. Okay. Okay. Can you guess how much? You can pause this video again. Yeah, of course, the easiest way is to swap 2 and 3, right? This is quite clear already. And then, yeah, you exchange 6 with 8 and then 6 with 7, yeah, because you know that 6 is here, yeah, so you need to move it twice, yeah, okay. So there are actually 3 minimum number of exchange that she needs to make the cards in ascending order. Okay, answer is 3. Hope it's clear, yeah. Okay, let's move on. This is the last question for rubric 3. Mrs. Sumira has just opened a small laundry service in her small house. She does not yet have an automatic clothes dryer, So the clothes must be dried by drying them in the sun. Mrs. Sumira doesn't even have adequate clotheslines, so she only uses a 2-meter long rope stretched out in front of her house. So remember, she only has a 2-meter long rope stretched out in front of her house. Okay, this is, you know that this is the constraint, right? I think it's clear, yeah, that this is the constraint. Okay. One day, Mrs. Sumira was asked to wash 9 towels of different sizes. In addition, of course, thinner towels will dry faster than thicker towels. So Mrs. Sumira tried to estimate the drying time of each towel and recorded it as follows. This is the towel number, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then this is the size of the towel, yeah, this is the size of the towel. And she calculated the drying time, yeah, because the thinner towels will dry faster than the thicker one, yeah? Okay, think it's clear? Okay, so now, because it is the rainy season, Mrs. Sumira only has a maximum of 4 hours to dry the towels, yeah? This is another constraint, yeah? This is constraint number 2. This is constraint number 2. Yeah, this is constraint number 1, yeah? So 2-meter long rope and only 4 hours to dry the towels. The question is, what is the maximum number of towels that can be dried by Mrs. Sumira? Maximum number of towels, yeah, this is the goal, yeah, maximum number of towels. Sorry, okay, maximum number of towels, that's the goal. Okay, now let's try to solve this problem. First of all, we need to calculate the shortest between length and width, yeah. You know that the shortest will be the width, yeah. Yeah, you don't want to use the length to dry the towel because it will consume more rope, yeah, than the shorter one. So calculate the shorter one. The shorter one will be 40, 20, 60, 80, 30, 40, 80, 50, and 30 for each of the towels, yeah, from 1 to 9. Okay, and then calculate. First, I think greedy algorithm can work well, yeah, here. So calculate the ones that will dry faster than the others. Yeah, so this one will dry faster, yeah, to only 2 hours. So you can switch them, yeah. Okay, after you dry these 3 first, and then you can switch with the other 3, yeah. Let's calculate the length that the 3 towels need. Okay, each of these 6 towels need 100 centimeter rope, yeah. So let's calculate here. 80 plus 30 plus 60 is 170 centimeters, right? How about the bottom one? Is 160 centimeter, right? 170 centimeter and 160 centimeter, and you can switch them. Yeah, you can switch. 2 hours and 2 hours each, right? So we have 30 centimeter left for the 20 centimeter towel. Basically, we have 30 centimeters left, right? But because you only have 30 centimeter left, then you cannot accommodate the 41. You cannot accommodate this one. You can only accommodate this one. Yeah, that needs 3 hours to dry. Yeah, so the answer is 7 towels. Yeah, so you can dry. So Mrs. Sumira can dry at maximum 7 towels, right? Okay. Okay. So basically for all of this rubric, yeah, you can try solving by yourself first. Yeah, you can pause my video first. Try to think creatively by yourself. And after that, you can check the question, the answer or the logic, yeah, by probably seeing my explanation on how to solve this problem. Yeah, I think that's the last of rubric 3. Yeah, again, this is a course on computational thinking. So you need to be able to think logically, creatively, systematically, yeah, in solving any problem. Yeah. Yeah. So first, what I mean by systematically is first You define the goal in any problem, define the goal, and then define the constraints. Because every problems will have a goal at least, or more than one goal, yeah, and it will also have constraints. Once you define this goal and constraints, yeah, constraints includes rules as well, yeah. Rules of the games, for example, yeah, that's also constraints, yeah. So you need to define these goals, constraints, rules of the games, and then think logically, creatively to define how to solve the problem systematically. Yeah, okay. So I think that's all for rubric 3. I will move on with rubric 4. Yeah, I will make another video to share with you on how to solve rubric 4. Yeah, thank you for listening. See you on the next video.